Welcome back to our grade 10 maths lessons. I am Miss Awidup, your maths teacher. In our last lesson, we had a look at the value of the polynomial and function notation. Okay, in today's lesson, we're going to look at two things because it's very important we know this before we solve polynomial functions. Okay, so we're going to look at the remainder theorem. Okay, remainder theorem and the factor theorem. Okay, remainder theorem and factor theorem. Now these two theories are very important because they help us to find factors of polynomials with degree of 3 or more. Okay, so we'll start with the remainder theorem. Okay, now the remainder theorem states that if we have, let's say, the function of x, all right, and it's divided by a linear polynomial, say x minus a, all right. Now the remainder will be given, all right, when we take the function of a, all right. Again, if we have the function of x divided by x minus a, then we find the remainder by using f of a or the function of a. Now let's see how we can use this factor theorem given a polynomial. Okay, so example, we have the function of x is equal to 3x plus 2. Okay, and this polynomial is divided by, okay, divided by x minus 1. Okay, linear polynomial. So the function of x, 3x plus 2, is divided by x minus 1. Go back to our remainder theorem here. It says if the function of x is divided by a linear polynomial, then we find the remainder by using the a value or the function of a. Okay, so how do we get that value of a? Now remember, when we looked at quadratic equations and we solved quadratic equations by finding the value of x. So here, that's what has been done. How did we do this? X minus 1 is equal to 0, and so x is equal to positive 1. All right? So, same thing applies here. If this linear polynomial is x minus 1, then the value of, or the function of x, the function of a here is going to be positive 1. All right? So, you substitute a into your polynomial here. So, p of x, or function of x, is equal to 3x plus 2. All right? That means the function of 1 is equal to 3x plus 2. All right? 3 times 1 plus 2 will give us a value of 5. So we have a remainder of 5. Now why is it important here? If you have a polynomial that is divided by another polynomial and you find remainders, that means that this linear polynomial cannot be a factor of that function. Okay? Now let's try a quadratic polynomial and see how this applies as well. Okay, so if we have, let's say this is example 1. We go to example number 2. All right, if we have the function of x equal to x squared plus 3x plus 3, and this is divided by x plus 2. All right. Again, we will see if we have a remainder. If there are remainders, then we cannot completely factorize this polynomial because they are not factors, all right? So let's have a look at x plus 2. We know here that the function of -2 is going to give us the remainder. Remember how we did it here? Same thing applies, okay? If we find the value of x here, x plus 2 equal to 0, x is therefore equal to -2. So we find the function of -2. Let's go. Function of -2 is equal to x squared plus 3x plus 3. All right. We substitute -2 into the equation. Excuse me, polynomial. -2 and plus 3. So we have 4 minus 6 plus 3. Our answer will be 4 minus 6 is -2 plus 3 will give us +1. Okay, so as you can see, where there are remainders, we know that the linear polynomial that we have divided by is not a factor of the function. Okay, now let's see when we have 0 remainders. So we're going to look at, remember this is the remainder theorem, we're going to look at the factor theorem. Okay, now simple division, we know that if you divide 12 by 3, you will get an answer of 4. Okay, because we know that 3 is a factor. All right, keep that in mind because that's the same idea we apply to polynomials. If you divide by a linear polynomial, okay, and there are no remainders, then we know that it is a factor of the function. Okay, so that factor theorem states that if p of, or the function of a, is equal to 0, then okay, x minus a is a factor, all right, is a factor of the function, all right. That's simply put, if your function of a is equal to 0 or 0 remainders, then we know that the linear polynomial here is a factor of the function, okay. So we use an example to show what this means. Let's have a look at function of x equal to x cubed minus 4x squared minus 7x plus 10. Now we do not have a linear polynomial here to divide by. We are trying to find that factor, okay? So what do we do to find the factor? You look at the last term here, or the constant. You need to find the factors of +10. We have -1 and -10. And we also have +1 and +10. Now, because +1 is the smallest, or not the smallest number, but the easiest number to work with, we are going to use +1. Now, remember, we are doing the opposite of what we did here. Okay? If this is +1, then if I form a linear polynomial, then it will be -1 inside the brackets. Okay? So again, opposite of this. So we will divide by, okay, +1. So in the brackets, it will be -1. All right? So we have identified a linear polynomial to work with. We are now going to try to prove if this is really a factor of the function. Okay, so we do long division. We've already done this, so we will very quickly divide and see if we get 0 remainders. Okay. So as you can see, after we've completed long division, we end up with 2 terms down here. When you subtract, you end up with 0. Okay, so we find that there are no remainders. When you have a case like this where there are no remainders, that means that this linear polynomial that you have used is a factor of the function given in the example. Okay, now that brings us to the end of our lesson. In the next lesson, we are going to look at how we use both these theorems to factorize an equation, a polynomial function. Okay, and in factorizing, we are going to follow through by solving the equation. Okay, I hope you join me for the next lesson. See you then.